Hello everyone, welcome to this tutorial. In this video, we are going to learn about what is Agentic RAG with help of PhiData. So in previous videos, we learned about PhiData and its use cases, and we went over multiple topics. So just to give a glimpse what we learned earlier, let me jump upon. So we learned about uh, agent, how to build a agent, and with that agent, how we can provide image as an input and search it. Right. Then we learned about multi-agents, how to build a multi-agent. So we had this web agent, finance agents, and then we built agent team. And according to prompt, it's went over and it's did all these uh, instructions, and accordingly it's did reasoning and connected with the different agent to it. Then we build one research agent. So research agents, what it does, it goes to our XIAI, which is a kind of materialized data set for all research and documents. So it goes there, and from there, based on the prompts, instructions, it does reasoning and fetch it out and all those related information and generate article based on this instruction automatically. So at the end of that, we were able to get this articles published in the Markdown. Now, in this tutorial, we are going to learn how we can build a agentic RAG. So let's try to understand what is a agentic RAG, right? So we have been hearing RAG since long with the LLM. It's nothing but RAG itself. It's just extension or usage of that RAG with agents. So that's why it is getting called agentic RAG. So let's understand in a bit, right? So from here, left side, there is a query, right? User can throw out queries. So in RAG, what happens? It does augments that query. How it does augmentation means whatever you are querying, it will go and reflect on your uh, local RAG DB, right? So to understand it's more clearly, before this, what we do, we uh, create a vector DB, right? So I think let's learn a RAG, how RAG actually getting built. Then we will come to this point for agentic RAG. So let's learn RAG. What is RAG, right? Uh, Before retrieval, we do embedding of all the uh, our proprietary knowledge based embedding, right? So let's learn that one. So here, this is the retrieval augmentation pipeline purview. So here, very first time, we need we need to ground LLM on our local data sets, right? So first of all, we will try to understand why we need RAG. As we already know, LLMs are trained on very vast amount of data. Uh, it's approximately, it has all internet data into it, and it has all those knowledge, right? But it's not aware of our private data, our corporate data, or particular which are the personal data, right? So how I will make LLMs aware of my own data, and to do that, either we need to train those retrain those LLMs on our data, which is not possible because of huge amount of cost and corpus of data required for that. But RAG is the way where we can provide a context to LLM about our local data, our proprietary data. So to uh, make those LLM aware of our proprietary data or local data, what we do some kind of RAG. So in that RAG, very first time, what it required for us is we need a vector database, and we need to store those local context into vector. Why do we need that? Because LLMs are storing all those data in binary format. That is nothing but they have uh, embedding into it, and they knows they have kept all those data uh, after embedding in a multi-dimensional vector database kind of things, and they provides semantic search, right? So that's why we, instead of embedding or instead of sending our uh, whole text as an input to LLM as a context, what we can do that we can only pass the context in form of uh, binary, right? And then we can ask the question, and then LLM can do some uh, acceleration around those questions and find the answer based on whatever context we have sent to it. So to do that, very first time, whatever enterprise or private data we have, we need to process those documents and do the embedding with any model which is compatible with LLMs, whatever LLMs we are using. And after doing embedding, we need to store those embedded data in a vector DB. So here, in very first sequence, we are doing document processing, means reading all those documents, and then those documents need to embed it. And after embedding, it will go and sit into a vector database. There will be multiple other sub process into it, because we have to do chunking and all those, right? So chunking, encoding, embedding, and all those stuffs required. But at high level, you can understand enterprise PDF. For example, one PDF or multiple PDFs we have processed it, and we have embedded with a model and generated embedding and then persisted into a vector database. So that's the very first process we have to do. Now, if we would like to ask a question and get answer instead of LLM's LLM's knowledge base, I would like to ask about my data set which I have given, right? So for example, I have my all HR policies rules in a PDF, just I processed, embedded, and stored in a vector database. Now I'm building a capabilities, for example, a chatbot, and I'm going to offer this chatbot as a HR assistant. And what it will do, it will allow user to query on those HR policies. And based on that query, this chatbot will be able to answer um, relevant information from corporate HR policies. So when user will ask a question, what it does, that query again will get embedded. And based on that embedding, what it will do, it will go and query all relevant chunk of data from the vector database. And then it will become as a context, right? Because we already have a query. So prompt query and retrieved enhanced context will go as a context to the LLM, and then LLM will answer those questions based on the context and responses back to the user. So this is the whole process of RAG. So in RAG, first document ingestion required, and then user query or retrievals is the consumption side, right? So in the agentic RAG, what we are going to do here, we have a query, and this is the bot or any web app, anything we can consider, right? And this is the agent actually. This will be acting as an agent, and this agent will be answering question based on whatever query we have, and based on the reasoning, it will decide which tool I have to go and make a call. Do I need to go for vector search engine A, which is for example my HR policy, vector search engine B, which is nothing but all financial records. It's been embedded here. And third one is calculator. If I am having a tool for calculator, it will go and it will interact with that tool. Or if it is open web search, it will go and do open web search. And from there, it will get information, and then it will be going to LLM. LLM will orchestrate the response, and then it will give response back. So hopefully I am able to make you understand what is agentic RAG at high level, right? So in context of PhiData, what we need to do. So PhiData is pretty much uh, providing a lot of capability out of box here. So we don't need to worry much about that. And we need to install few stuffs, right? Uh, so for that, we need to install packages related with PhiData. So with PhiData, we have to install in our requirement.txt. You can go and see that PhiData. And OpenAI is the model which I'm going to use for our model inferencing and all those stuffs. This is not required. This was from earlier use cases. Then what I need, let's go to Agentic RAG. Then I'm using PDF, right? So I'm going to process PDF. So the PhiData, knowledge, and embedder also, right? So it uses open embedder, OpenAI embedder. So we already having OpenAI embedder here. And for knowledge retrievals and augmentation, I'm going to process PDF. So I need a PDF knowledge base, all right? And then I need a vector DB. And from vector DBs, I need one of the vector DB, which is Lance DB, right? So for that, I need a Lance DB. So Lance DB need to be installed. So that's why I have installed Lance DB and PDF here. So if you will click, it has to go and it has to install. And in other way, if you would like to have all this in requirement.txt, just you will, the way I showed you, you should be able to place here, and you will run in this notebook, it will go and install all the packages mentioned there. So as usual, this here we are going to import a couple of libraries which is required for our code, and then we need to load environment variables, which is nothing but I am having uh, uh, OpenAI API keys. So that need to be imported here. And then in this cell, what I'm going to do, I have a simple PDF from here, and I will be using this PDF for my local knowledge base. So to create a knowledge base, I'm using this PDF. Let's open this PDF and see, it's nothing but the recipe, right? So this is Thai recipe notebook, PDF, right? Man, it seems like it's a menu of Thai restaurant, and we will be using this PDF as a knowledge base, and we will be querying based on that, right? So to build a knowledge base, I am using PDF URL knowledge base, which is nothing but it's abstraction provided by PhiData itself, right? So you will see here, this PDF URL knowledge base is PhiData knowledge base PDF, and it has all the wrapper classes. Just you need to pass a URL, and then after giving this URL, you need to embed, right? And to embed, you will be using OpenAI embedder. And there we are giving the model text embedding 3 small. So it will use this model for embedding, and it will generate the embedding. After generating embedding, what we have to do as a part of this process, after embedding here, we got the document, we are embedding here. Now we have to store in vector DB. So for that, we need a vector DB. So that's where we are passing vector DB, which is nothing but Lance DB. And we are giving a table name. It will be recipe, and where I would like to store, I will like to store in temp folder and underneath Lance DB. And search type, it will support vector. So only with this few line of code, I'm able to do RAG. And that's how PhiData call it. It's a auto RAG. So let me delete this LansDB folder from temp, and we will see it will create LansDB, right? And I will load here. Just I need to load all these embedded information into that LansDB vector database, right? And after that, we will have a new agent, and this agent will have this brain, which is OpenAI chat, and GPT 4.0 model, and the knowledge. I'm saying that, hey, now you have this knowledge base. So I'm grounding this agent with this knowledge, right? And tool call true and markdown true, so that it will show all those information. So now I have constructed a one agent. Now with this agent, I'm saying that print a response, and what I'm saying, how do I make chicken and glangal in the coconut milk soup? This is my question, and it will reason on this knowledge base, and it has to give the information. With that explanation, let me start running this. So we we install LansDB and PDF file, right? PyPDF, and then import necessary classes, importing environment variables. Now I'm creating a knowledge base object. So see, it has created LansDB and all structured, right? Recipes. And when I will load, it will load the data. So now it will say that it will create a collection, then load knowledge base by reading this particular PDF. Okay, so it's taking time. It will take a few time to load, and you can see here. Yeah, so all this data getting loaded here. So it has loaded all this data here. And what it says that added 14 documents to the knowledge base. So now you can see auto chunking it has did, right? I have given only one PDF, but it did chunking and it's made 14 document out of it. Now I will run this agent construct. Let me build this agent. And now I'm going to ask this question. Let's see what's response coming. So, okay, this is some warning. Didn't got any information as the output. Okay, I didn't save this document. It doesn't matter, right? Should give output. So, okay. So, uh, there is an issue the way it's spit out the output. So in our notebook, we are not able to see the output because it's a stream equal to true. Let me remove it, string, make it a stream equal to false. So we should be able to get that response. So you can see some response is coming up, right? Otherwise, meanwhile, we will wait for it. Again, this response doesn't shows up here. So what I did, same code, I have wrote into RAG underscore agent Python file. You can see, right? And then I'm loading that knowledge base, building agent construct, and asking this question. So after running this, here you can see it is able to reason and give the answer, right? So I'm running rank agent.python and what it does first, it's creating collection, loading knowledge base, reading from this, right? And it says that added 0 documents. Why? Because there is no change. I have already ragged it, right? So now the question we are passing it a message, how do I make chicken and galangal in the uh, coconut milk soup? So here you can see it's running and it's going searching knowledge base with this query, right? And then to make a chicken, this also known as this, and it's giving some more information. And finally, it is giving ingredient, and this is the whole ingredients in English, right? You are able to see all the steps and things been given. So if you will see how simple this code has become, right, for a agentic RAG. And here, this PDF, you will see this is the menu, right? It's automatically extracted and it's able to give uh, all the steps which need to be followed. So with this PhiData, you are able to see how simple it has been, right? To create a RAG agent and in very few line of code. So that's the beauty of PhiData, which provides a lot of abstraction and framework level capabilities. Just you need to know how to do the RAG, what are the commands and components, and then you should be able to build RAG agents within few line of code. So that's all from this topic. Feel free to comment if you guys has any other thought. I will see and we will have another tutorial around it.